Division. Division of fractions. Well, first, what do I mean if I talk about division? We're now still on the left intuitive side as much as possible, right? So if I say, like I had there in the example, how do I understand this? This is a sentence, a mathematical sentence. The equal sign is sort of the verb. 100 divided by 5 equals 20. How do I intuitively make sense of that? Well, I could say I have 100 people, and I break them up into groups of 5. How many groups are there? 100 people, groups of 5, then there are 20 different groups. I think everyone feels that is fairly intuitive, and that's how you start talking about division as well. I'm dividing the larger group into smaller groups. How many groups are there? That's division. So when I now talk about fractions, it's not any different. I'm still trying to be as intuitive as possible. So if I have, this is a diagram there, 1 4/5 divided by 2/3. It's no different. I'm still having this first number as my quantity that I have, and I'm trying to see how many times does a group of 5 people fit into this 100. That number of times that I can fit this in is the answer. So this, or number of times we can fit 5 into 100. That's an alternative way of intuitively interpreting division. So now I have my first number, and I don't have a lot of space. That's okay. I have 1, and another little portion of a whole rectangle. So I have this 1 whole rectangle and 4/5. Let's go fifths like this. Sort of equal, not really. That's okay. And I have 4 of them. That's what I have. Now I'm trying to see how many times can I fit 2/3 of a rectangle into what I have. But I can't see 2/3. So I'm going to go sideways again. Let me just do the fifths here as well. So everything is the same throughout. I'm now going to go sideways with thirds. I don't have these, right? This isn't what I have. But it is a part of the whole rectangle. Here's what I have, breaking it up into thirds, so I can see it. Now, 2/3 of a whole. 2/3 of a whole. How many would that be? 2/3 of a whole is how many of those little guys, those little squares? They're not really squares, but how many squares? How many squares is
10.
2/3? 10. Because I have a whole rectangle here that I can look at. 1, 2, 3, 4, 5, 6, 10 of those little squares make up 2/3. Now I'm trying to see, okay, so this is my group size. This is my 5. How many times can I fit 5 into 100? How many times can I fit 10 of these squares into what I have? So let's use a color, blue. So I can fit it in once there, once. So I'm making groups of 10 squares. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, maybe like that. Doesn't matter which order they are, as long as I group them. But in groups of 10, that's 10, right? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Oh, it's not enough for another whole group. So, I can fit it in twice. Let's say 2 times with, how many left over did I say? 7. 7 of these guys left over. So 7 is sort of my remainder, but I can't say 7 because it's 7 little rectangles. So here's the thing. Now I want to write my answer. How do I write my answer? Well, it's 2. 2 whole times can I fit in 2/3. And how much of my 10 can I fit in? 7 out of the 10 that I need. So 7/10 of another group can fit in. It's a little high. Why do I move it so high? So that is an intuitive way to not rely on any mathematical properties, just with rectangles to get the answer. Now you have a calculator, you can do it in your head, you have many other options. Once you move to the right from that all intuitive side to verify your answer. But I'm looking at the first quantity is what I have. The first number is the quantity I have. Then this is what I'm trying to fit in. How many times can I fit this in? Well, how much is this second quantity? In terms of little rectangles, it was 10 in our case. How many times can I fit that in? Groups of 10. One group of 10, another group of 10, and I don't have enough left. I have a portion of that left. So 7 out of the 10 that I need, I can fit in. So 7/10 of another group I can fit in. So I can fit 2/3 into this twice in 7/10 of a time, I guess. How does that feel? It's the most complicated of the 4 operations. So of course the method, though all intuitive, is still not as simple. But it does get better by example. Exercise 410, 5, 6, so divided by, or 1410, 1, 5, 6 divided by a quarter. All right. So again, I need to show enough for us to just show that I understand this method. When you're actually teaching it, then you can elaborate where it needs to and do much more. But we don't need to go that extreme to show that we understand. So we have our first quantity, which is the first number, 6. So 6 pieces, oh no, not that one. Like this. I don't have all of them, only 5 of them. So I don't really have this guy. Like that. That's what I have. I'm trying to fit in a quarter of a whole rectangle. Not a quarter of this. That's multiplication. This is not the same. Quarter of a whole rectangle is represented by 1. Well, I have no idea. I have to break this up into quarters. I don't really have those, but they're there. A quarter of a whole is how many little squares. Note that I'm not shading those squares, just of a whole rectangle. How many make up a quarter of that rectangle? 6. 1, 2, 3, 4, 5, 6. So that's my group size. So now the question of division becomes, how many times can I fit 6 in squares into what I have? Now I only have this, I don't have those. 6, right? There's 6 there, so that's once. There's 6, 1, 2, 3, 4, 5, 6, oh, 6 there. Like so. That's twice. 1, 2, 3, 4, 5, 6. Another 6 can fit in. So that's 3 times. And then I have 2 left. So 2 out of the 6 that I need can fit. So we can fit 6 of my little squares 3 times with 2 left over. So the answer is 3 and 2 over 6. 2/6 of another time, of another group I can fit in, not a whole group. Only a fraction of another group. Any questions or thoughts on that? No thought? It's Monday. Too easy? I don't think so. I think it's the worst of the 4. It's definitely the worst one. But division is less intuitive than addition, subtraction, multiplication for sure. So I'm not expecting the most intuitive method to be that great. But it's the best that we can do. Not using any mathematical properties whatsoever. Second one. 1/5 divided by 2/3. It does test my intuition. It does. Whoa. Because the second number is bigger than the first. I can still find an answer though. This is my first quantity, 1/5. So let's break that up into fifths. I don't have them all. I only have 1. Oh. I don't have any of this. Kind of like dotted lines, but do whatever you want. I only have a little bit. Now I want to see 2/3 of a whole is how much? I can't see thirds, so I'm going to have to go thirds here. 2/3 of a whole is how many of these little squares? Of a whole rectangle, not of what I have. 10. Because if I have a fraction just as a representation of a quantity, it represents a portion of a whole rectangle, regardless of what I have to work with. It's a portion of the whole rectangle. So it's 10 little squares. So the question is still, how many times can I fit in 10 squares into what I have? Can fit 10 of my 10 squares. How many times? 0 times. 0 times. With 3 left over. So the answer is, yes, as a mixed number, I'll write this temporarily, 0 and 3/10. But we don't write the 0. We just write the 3/10. It's a little weird. It's a little weird. Definitely need some practice to get used to this, but it's the most intuitive I can come up with for division without maybe having some object or nicer numbers. Of course, nicer numbers, and there's no issue. 100 divided by 5, everyone's going to say that's 20, or it's easy to figure out. This, a little less so. And as the numbers get more complicated, I do want to move away from that intuitive side because it doesn't feel that intuitive anymore. It feels a little shaky, perhaps. But it still works. It still works. Any questions or comments on that one? Too much for a Monday? We only have so many Mondays left. Like 2 Mondays left, 3 Mondays left. Not a lot of Mondays left. So it's good. 2¼ divided by 2/3. That one's going to feel a little better because the first number is bigger. Feels better because I have more to work with. And I'm also, yeah. Just makes it somehow easier, though it's in no way different. Oh, did I make these too big? 2 whole rectangles and 1/4 of another one. A little bit, I don't really have any of this, though it is there for my whole rectangle. Okay, now I'm looking at 2/3 of a whole. What does that represent? Well, I'm going to have to break this up into thirds to see, and I've already used the columns. I should probably do quarters here as well, right? So I can see all the same kind of piece, little square. So how many squares represent or correspond to 2/3?
8.
Only 8, because 2/3 is 2/3 of a single whole rectangle. So 2 rows out of 3, 8. So regardless of what I have. Now I'm trying to make groups of 8 in what I have. So I have 1, 2, 3, 4, 5, 6, 7, 8 here. That's one group. 1, 2, 3, 4, 5, 6, 7, 8 is another group. The gap doesn't count. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, that's nice. That is a third group. 1, 2, 3. Oh, it's not enough. Not enough. So we can fit these guys, 8 little squares, into what I have 3 times, with 3 left over. So the answer is therefore 3 and 3/8.
Yes. Just for the quiz, are you going to want us to include the task, like the writing, like 2/3 of a whole equals 8, just explaining it?
Ask yourself this. If I don't have that, is it perfectly clear what you're doing without you being there to explain it? Not really. So that it helps. Whatever you then need, so that it stands on its own. If the better your diagram is, yes, the less you have to write down. You can write down a lot and have a sketchy diagram. Get it? Sketchy. So it depends. Just ask yourself the question. That should be the question throughout. Any quiz question, really. Can this stand on its own? Or does it need me there to explain it? So if it stands on its own, then it's good enough. If it needs you there, then it's not good enough. It's not clear enough. Any other questions? I know division is a favorite. You're just so overcome with joy to do this that you can't speak. Well, what if the second number is a mixed number? We can't not address that. Like 7/8 divided by 1 2/3. Of course, the first number could be much bigger, but it really doesn't matter. And having that first number smaller than the second really tests if I understand this method. And if I don't perfectly understand this method, little Timmy's going to have no chance. I have 7/8. It's a little annoying, but on the larger side of the diagrams that I'm expected to do, and I have 7 of it there. Don't really have this. There you go. My method's the same, nothing has changed. It's not necessarily the most efficient thing ever, but it is purely intuitive, or purely on the left side, as intuitive as division can be. So 1 2/3 of a whole, remember that's always implied, is, well, I don't even see little squares, right? So I'm going to have to do this in thirds to have little squares. How many little squares correspond to 1 2/3? Not easy. And if you find this not easy, it's a good thing, because it gives you an appreciation for the struggle Timmy is going to face one day. And if you don't appreciate the struggle, you can't help him. I don't know the answer, because I don't see enough to have this big quantity. So make more. It's not really there, but it's there for me to figure out this larger mixed number and see more, sort of see more of those little squares. So 1 2/3 is how many of those little squares? A lot. How many?
I think 40.
40, yes. Nice. Why 40?
One whole.
That gives me already 24, all of this. And then, that's the 1.
And then 16 more.
And then another 2 rows of 3, that's another 16, it's 40. Nice. Tricky, but nice. So the question is still, how many times can I fit in 40, a group of 40 into what I have? Obviously 0 times. We can fit in 40 0 times. I don't have nearly enough. With, how many is this? 21? 21 squares left over. And therefore my answer is 21 40ths. Really doesn't get any better than this with fractions. It's one of the 2 things that most kids, I don't want to use the word hate, but it is the appropriate word. Hate, fear, dislike, but why? Because it doesn't feel intuitive after all. If you don't have nice numbers that fit in nicely, work together, it's not intuitive. You can try and stay on the intuitive side, but it's not. How intuitive is this? Doesn't feel very intuitive to me. And the danger in teaching, or not danger, danger, comes in when teachers try and stay on that left intuitive side when that's not efficient anymore. The numbers are just unpleasant to work with on that left side, but they don't have the ability, the knowledge, the skill, the understanding to move away from that and ask, why, what is division really? And how can we make sense of it mathematically to help us understand and perform calculations efficiently? Still understand and perform calculations efficiently. So the next section is then titled accordingly, Understanding Division. Let's go back to our clock. Not our clock, our circle. Counting on a circle. I'm not going to use a 12. I'm going to use, like, I don't know, let's go with 7. Can I use 7? Down I use 7, yes. Now if it breaks up to 7, that can't be good. 3 and 4 here. Like that. That looks 7-ish. 1, 2, 3, 4, 5, 6. Come on, 7. So the reason why I'm doing this is to really look at what division means before I go to my more familiar, more comfortably named numbers on my number line. It's going to be okay. Sorry, just before we do that, before this, don't look at this. Before that, just normal number line. I just forgot to do this first. Normal number line, no circle. Normal, usual, comfortable. Let's take something simple, right? That I can find and I can say that sentence in an intuitive way. Can be totally understand. Take pieces of candy, break it up, split it up among 3 kids. How many does each kid have? Perfectly intuitive division sentence. But I can rephrase this. So this sentence is equivalent, meaning it has exactly the same information. It's just a rephrasing of the sentence. I can rephrase this as a multiplication sentence. 2 times 3 equals 6. Because if I have 3 kids, each one has 2 pieces of candy. How many pieces of candy do I have? Now it's a multiplication sentence, not division anymore. These two are the same. It's like saying one thing and saying it in a more casual way, but you're saying the same thing. So any division sentence can be rewritten as a multiplication sentence this way. What's the easy way to do this? You just go backwards, that becomes a times, and that becomes an equal. Though, not really what I'm going to do, but it's an easy check. I do want to understand how to rewrite things. Everyone happy with this? Very intuitive. Nothing, there's no resistance, perfectly natural. And I'm going to an easier operation. That's even more intuitive. Multiplication is even easier to intuitively think of than division. So it gives me a way, if I'm not sure about division, I can translate it, not really translate it, rewrite it, say it in a different way using an easier operation, multiplication. Let's keep that in mind. I can do that for any division sentence. Now, let's go, for example, mod 7. I have an example there, 5 divided by 2. So now if I want to figure out what is 5 divided by 2, and I'm working mod 7. This is just a side note to tell everyone I'm in the circle. I don't know what the answer is, right? Because now suddenly this makes no intuitive sense at all. Because I'm trying to see mathematically what does division mean. I'm stepping away from the intuitive side. So I'm not expecting this to make intuitive sense. I'm not expecting that, because it doesn't. But I can translate this to, let's put question mark in a box. It's a number, I just don't know what the number is. Trying to figure out what the number is. What is the rephrased multiplication sentence? Based on my intuitive simple numbers, 2, 3, and 6, I know how to rewrite it, regardless of how much sense it makes at the time. This is the equivalent multiplication sentence of this division sentence. I just went backwards. But this is easier to figure out, because multiplication is easier. I can now just do a guess and check to see what number could be this one. Can it be 1? Why not? Because 1 times 2 is not 5. It's 2. Can it be 2? Not really the emphatic no I was hoping for. 2 times 2 is 4. It's not the same. Can it be 3? No. 4? 5? It's one of those numbers. There's nothing. Do you see anything here? There's nothing there. It's empty space. It's a void. There's nothing else. The reason why I'm looking at the mod 7, in this case circle, is to get away from fractions for a second and just look at this. These are my options. The answer is here. Which one is it? 4? It can be 4. Because 4 times 2 is 8, mod 7 is 1. I'm looking for a 5. 5? 5 times 2 is 10, which is 3 mod 7. And I'm not looking for a 5. 6? 6 is the winner. Because 6 times 2 is 12, mod 7 is 5. It's one of those. Can't be anything else. There are no other numbers. When I'm looking at the circle, those are the only numbers. There's nothing else. Has to be one of them. And it's a 6. By trial and error. Trial and error. But because of the multiplication being more intuitive and easier to work with, I can find it. Yeah, it's not that convenient. I have to look through all of them, and if it's a big circle, it's going to take a while. But I can find it. I understand multiplication. It's not that strange. Even on a circle, I just loop back on the circle if I get a larger answer. It's all good. Because the risk of a seemingly getting a fraction is not there in multiplication. All right? So, the answer is 6. Let's go over here. Weird as that may look, 5 divided by 2 is 6 mod 7. It's not intuitive at all. It's a mathematical counting system that goes in a circle. There are no fractions. There is nothing. But I have an answer. 5 divided by 2 is 6. Now, if you look at the circle, chalk's getting really small. If you look at the circle, this circle, for example, for every number on the circle that's not 0, 0 special, 0 doesn't play well with others in multiplication. There is another number, let's say a partner, a friend, so that the product of the two is 1. Random number. 3. What'll give me 1? Mod 7. Trial and error. 1. Can it be 1? The friend of 3. What is 3's friend? So when I multiply them, I get a 1. Just go down the line. Can't be 1, then I get a 1. I get a 3. 3 times 2 is 6. No. 3 times 3, 9, which is 2 mod 7. 3 times 4, 12, which is 5 mod 7. 3 times 5, 15, which is 1. 5. Give me a random one. I didn't really pick 3 because it's special. Give me a random one. 5. What is 5's friend? So that together by multiplication they give me 1. 5 times 3 is 15, which is 1. Give me another one. You only have like 6 options. Not hard. Roll the dice.
4.
4. 4 times what? What is 4's friend? 4's friend is 2, because 4 times 2 is 8, which is 1. So, we call these multiplicative inverses. Multiplicative, because I'm multiplying. Inverses, because they sort of cancel each other. But now the cancellation result, when it comes to multiplication, is 1. Multiplicative inverses. Which space do I have? Some space. There's no space. Okay. So for a number, let's call it A, the multiplicative inverse is called, before I actually look at my circle, before I know exactly what I'm working with, A with a little -1 superscript. It's just a name. When it was an additive inverse, I put the negative in front, so I can't do that again. I have to put a sort of a negative indicates opposite, but it's a different kind of opposite, so I put a little -1 up at the top. I get just a negative would look kind of weird, so a little 1 there. So we can say, for example, 4 and 2, so the multiplicative inverse of 4 is 2 mod 7. I have to then say, what am I working with? Because a different size circle and the answer would be different. I can also say the multiplicative inverse of 2 is 4 mod 7. And so every other number, not 0, will have this friend, this multiplicative inverse. What's the point? What is the point here? Well, let's go back here and fill in my answer, which was 6, on my mod 7 circle using the 5 divided by 2 example. I'm going to look at another question, but multiplication. What is 5 times 4? Mod 7. Well, 5 times 4 is 20. 20 mod 7? 6. You can do this over and over and over for as many examples as you need. If I keep this first number the same, divide by something, I'll get the same answer as when I multiply by its multiplicative inverse. So these aren't random. They are connected. These are multiplicative inverses. So there's mathematical properties hiding behind these that tell me that division and multiplication are actually very closely related to each other. It's not a brand new operation. Division is really multiplication in disguise. Let's say it over here. Division by a number is really multiplication by its multiplicative inverse. Now, if I understand the mathematical structure and properties, I can now go back and say, I don't need to be on this left intuitive side. I understand how these things are actually related to each other, and I can be much more efficient in my calculations. So if I have division, this is the same as multiplication by the multiplicative inverse of this number, which happens to be 4 in this case. Let's do another completely random example. Let's go and give me a random number.
8.
8 divided by another random number, small, let's go small. 3, and let's go mod 11, why not? No idea what that is. Intuitively, it makes 0 sense, and I'm not ashamed to admit it. Anyone that claims that that makes sense purely intuitively, this is lying. It's no one. But I don't need to be. I'm stepping away from the intuitive side and saying that this is, well, not the whole thing, sorry. I can say 8 divided by 3 is the same as 8 times the multiplicative inverse of 3. Because that is the relationship between division and multiplication. There is no division, really. Just like there was no subtraction. It was really addition in disguise. There's no division, really. It's just multiplication in disguise. So now, mod 11, I just have to figure out, well, what is this guy when I'm working on a mod 11 circle? Now that'll take some trial and error, but everyone has one. 3 has a friend that we call multiplicative inverse. What is 3's friend? So that when I multiply them, I haven't even finished my sentence. I'll get a 1 mod 11. Yeah, okay, fine, 4. Because 3 times 4 is 12, which will give me the 1. So 3's inverse is 4. And now I've rewritten this to multiplication, which feels so much nicer and easier to work with. 8 times 4 is 32. 32 mod 11.
10.
So the answer up here is 10. I did skip some exercises because I didn't look at the book. It's not that big deal. Exercise 1411. Didn't we? Wow, this was total coincidence. Or did someone look at this when they picked 3 in? I picked 11 though. I didn't know. Exercise 14.11. Number 1 is exactly that. 3's inverse is 4. Wow. Kind of nice how things work out. Inverse of 4, mod 5. It's hard, I have to run through numbers. 4 times what is 1 mod 5? 4 times 1, 4 times 2 is 8, that's 3 now. 4 times 3, that's 12. Mod 5 is not 1. 4 times 4, 16. That's 1. So in some situations, the number is a little lonely. It doesn't have any friends. What do you do when you have no friends? You're going to be your own friend. Yeah, sure. I remember, side note, which is kind of sad, but it's true. In English class, somewhere in high school, I can't remember. We had to, the teacher gave us the topic, and then we have to go write an essay or prepare or something. I can't remember what it was. And the topic was my best friend. And without really thinking about who was listening, I said out loud, I'm my own best friend. And everyone laughed. Didn't understand why. You have to be your own best friend. Don't you? No one knows you better than you. Everyone laughed at me. Still don't understand why. Because that was true. But in this case, I guess perhaps it's not always true. No, what if you do 4? Mod 5. In this case, 4 is its own best friend. No one else wants to play with 4. So the number could be its own multiplicative inverse as well. That happens sometimes, but still, it's a number on that circle. 2, 7. Multiplicative inverse of 2 mod 7. 2 times 1, 2 times 2, 2 times 3, 2 times 4. This 4 has got nothing to do with this 4 because the size of the circle is different. Alright, this is the insert for exercise 1412, where we have some phrases, division phrases, not sentences, because we don't have an equal sign or something like that, which sort of serves as the verb. So we don't have a full sentence, we have a phrase, division phrase, convert that to a multiplication. So the first one is 5 divided by 3, and I'm working mod 11. Now we've discussed and seen that there's really no division. Division by a number is multiplication by its multiplicative inverse. So now I have to find what is the multiplicative inverse of 3 mod 11. Well, 3 times what
gives me 1. I'll do it on the side here. 3 times 1 is not 1. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12, which is 1 mod 11. So the multiplicative inverse of 3 mod 11 is 4. Then I might as well finish it. Technically that's all the question is asking for, but I might as well finish it. 5 times 4 is 20. 20 mod 11 is 9. So by working on the mod circle, I really have to look at this because it looks, and think about what is happening here, because it looks much less familiar. Number 2, 2 divided by 4. 2 divided by 4. You might be tempted to say, oh, but it's a half. No, there are no fractions on the mod 5 circle. My answer is going to be a number 0 to 4. Those are the only numbers available. So I rewrite this to multiplication. Division by a number is the same as multiplication by its multiplicative inverse. And then I have to find, well, what is the multiplicative inverse of 4 mod 5? Well, 4 times what is 1 mod 5. 4 times 1, obviously not. 4 times 2 is 8, which is 3 mod 5. 4 times 3 is 12, which is 2 mod 5. 4 times 4 is 16, which is 1 mod 5. So in this case, 4 is its own multiplicative inverse. That can happen as well. And then I might as well finish it. 2 times 4 is 8. 8 mod 5 is 3. So we're writing the division into an equivalent multiplication. Let's do the last one. Number 3, where we have 5 divided by 2. 5 divided by 2, and I'm working mod 7. So that is equivalent to, division by number is equivalent to multiplication by its multiplicative inverse. Now mod 7, what is the multiplicative inverse of 2? So I'm looking for 2 times what is 1 mod 7. It's not 2 times 1. 2 times 2 is 4. 2 times 3 is 6, so that's not it. 2 times 4 is 8, which is 1 mod 7. So the multiplicative inverse of 2 is 4 mod 7. And I might as well finish it again. 5 times 4 is 20. 20 mod 7 is 6. Because I can take away 2 multiples of 7 and then I have a number less than 7 left. So what is the point of all this? The point was to just go out of your comfort zone a little bit to something that doesn't look as familiar, and then you really have to stop and think about what we're doing in the relationship and what does division mean? How do I work with division? What is its relationship with multiplication? It has a very strong relationship by way of these multiplicative inverses. So now if I go back to fractions, we have a much better understanding of what to do with a division calculation when the numbers aren't convenient for an intuitive rectangle approach. If I take an example different from the book, I'll just take like 3/4 divided by, I don't know, 2/5. Yes, I can do it with a rectangle, but the numbers could have been much bigger as well. How do I move away from the intuitive to a mathematical understanding where the size of the numbers don't really matter at all? Well, now I can see division as multiplication by the multiplicative inverse of this number, which is a fraction. I'm not using a mod circle anymore. I have my number line, so there are many, many numbers. Now, what is the multiplicative inverse? Sorry, just an equal there. What is the multiplicative inverse of 2 over 5? Well, what do I have to multiply 2 over 5 by to get 1? Clearly 5 over 2. So the multiplicative inverse of 2 over 5 is 5 over 2. And if I multiplication is much easier than division, it's simply 3 times 5 over 4 times 2. And I can simplify that as 15 over 8, or if you want 1 and 7/8. So when the numbers get less convenient, I'm going to have to move from the intuitive side to a calculation side, and the rules or properties for how these things are done come from the relationship between them. Everything's connected, and an understanding of that creates confidence and the ability to handle anything. And you have to be able to move back and forth depending on your audience when you're teaching as well. They need to understand first, and then as things get more technical, you move away from the diagrams to the more efficient methods. But that comes with a required mathematical understanding that you need to have more than your students.